So I'm Justin Mehl, and I'm with the Department of Chemical Engineering.
Hi, I'm Rebecca, and I am in the Department of Geosciences. I'm a senior.
So talk to us about your project.
Okay. So what we did this summer is we were testing the effect of calcite, the main component of limestone, on the formation of iron oxide crystals. So what we did was we made 4 samples, each containing aqueous iron at a certain concentration. And then we tested the effects of different calcite components on the formation of iron oxide crystals. So you can see here in our table we've got 1 sample with calcite, 1 sample with aqueous calcium, and 1 sample with carbonate. So the calcium and carbonate are both components of calcite. And what we did was we incubated those in a 70-degree oven at a pH 7.5, which we maintained by titrating twice a day. And we took Raman and infrared spectra over the course of an 11-day period. And you can see here we've plotted the half-peak widths of this Raman spectra. So essentially what we did was we shined a laser on our samples, and we could characterize our samples by the readout that the machine gave us. And essentially here you've got a plot of the crystallinity as a function of time, and you can see a decrease in crystallinity in our hematite samples. And you can also see that we formed hematite, which is a more stable form of iron oxide in the presence of calcium-containing iron solutions.
Sure. Yeah, so the applications are kind of twofold. So the first, of course, is, environmental systems, right? And that's what everyone cares about. So if you look at systems in the natural world that have a lot of calcite in them, most systems also have a lot of iron. So if you look at something like a soil sample that has a lot of calcite, those are called calcareous soils. They tend to be in very arid, dry regions. And it's unclear as to what the chemical interactions between calcite and iron are. So hopefully by doing this in the lab, we can sort of elucidate what could be going on chemically between those components and possibly verify out in the field that maybe calcite is having this influence on what kind of iron oxide is precipitating out in these systems, which would have some implications for how we understand some geochemical cycles and processes. The other application is that we want to use an iron oxide coated calcite material or limestone to remove arsenic from drinking water. And we know that from the literature that iron oxides are very good at removing arsenic from drinking water. So when you use a calcite substrate, you can basically have these really tiny iron oxide crystals giving you a lot of surface area for that arsenic removal and maintain a large enough grain size for it to still be effective as a filter. So we wanted to basically know what kind of iron oxide is forming there so we know what we're using when we do that eventually.